Mobile ad hoc networks, decentralized wireless communication. Mobile ad hoc networks, MANETs, are decentralized wireless communication networks that can be formed on the fly without the need for any pre-existing infrastructure. In MANETs, mobile devices act as host and router and communicate with one another in a peer-to-peer fashion. In this article, we will discuss the fundamentals of MANETs, its advantages and disadvantages, routing protocols, and current research areas. Fundamentals of MANETs. MANETs consist of mobile nodes that can move freely and connect to each other without the need for any centralized control. Each mobile node in the network can act as a source, a router, and a destination. In other words, each node is mobile and self-organizing, and can establish short-lived connections with other nodes within its radio range. These nodes can join or leave the network at any point in time without affecting the network's functionality. In MANETs, each mobile node also has limited communication capabilities in terms of transmission power and battery life. Therefore, it is essential to establish energy-efficient, robust, and scalable communication protocols to support the network's efficient operation. Advantages and disadvantages. The most significant advantage of MANETs is their ability to set up a communication network in places where there is limited or no infrastructure. For example, in military operations, a squad of soldiers can form a MANET to communicate with each other in an area where there is no pre-existing communication infrastructure. MANETs can also be used in disaster response scenarios, where the existing infrastructure is damaged or destroyed. Another benefit of MANETs is their flexibility and adaptability. Since each node can act as a router, the network can quickly adapt to changes in the topology, such as nodes joining or leaving the network, or changes in the signal strength between nodes. However, there are also several disadvantages of MANETs. One of the most significant drawbacks is its vulnerability to security threats. The decentralized nature of MANETs makes them susceptible to security attacks, such as malicious nodes, eavesdropping, and denial of service attacks. Additionally, since each node has limited communication capabilities, the network's bandwidth and throughput are also limited. This limitation is especially crucial in applications that require high data rates, such as multimedia transmission and real-time communication. Routing protocols. Routing protocols are essential in MANETs to establish communication paths between nodes. There are two main types of routing protocols in MANETs: proactive and reactive. Proactive routing protocols, also known as table-driven protocols, use a periodic exchange of routing information between nodes to maintain a consistent view of the network topology. Examples of proactive protocols are the Destination Sequence Distance Vector (DSDV) protocol and the Optimized Link State Routing (OLSR) protocol. DSDV uses fixed links to maintain a consistent view of the network topology, while OLSR uses multiple paths to enhance the network's reliability. Reactive routing protocols, also known as on-demand protocols, only establish communication paths when needed. Examples of reactive protocols are the ad hoc on-demand distance vector (ODV) protocol and the dynamic source routing (DSR) protocol. ODV uses route discovery messages to establish a communication path between nodes, while DSR uses source routing, where the sender specifies the route it wants the data to take. Current research areas. Several research areas are exploring ways to improve the performance of MANETs in terms of reliability, scalability, and security. One of the most popular areas is the development of hybrid routing protocols that combine both proactive and reactive protocols. Hybrid protocols, such as Zone Routing Protocol, ZRP, use proactive protocols in a local neighborhood and reactive protocols for long-distance communication. Another area of research is the development of energy-efficient routing protocols. Since each node in a MANET has limited energy, it is essential to establish routing protocols that conserve energy. How maintaining network connectivity. Examples of energy-efficient routing protocols are energy-aware routing, EAR, protocol, and geographic and energy-aware routing, GEAR, protocol. Additionally, several research studies are investigating ways to improve the security of MANETs. One proposed solution is the use of trust-based routing protocols, where nodes establish trust relationships with each other based on their behavior. Another solution is to use encryption techniques to secure the data transmitted over the network. Mobile ad hoc networks, MANETs, have evolved significantly since their inception. From their initial use in disaster response and military operations, they have now found applications in a range of scenarios, including remote areas, transportation, and smart cities. Today, MANETs operate in highly dynamic environments with a large number of mobile devices, making them challenging to manage effectively. One of the significant advancements in MANETs has been the development of cognitive radio technology, which enables nodes to identify and use available communication channels in real time. This technology is useful in MANETs, where the radio spectrum is scarce, and different devices need to share the same communication channels. Cognitive radio can significantly improve the network's performance by providing more reliable and efficient communication. Another area of research in MANETs is the development of quality of service (QoS) protocols that can provide guaranteed levels of service for different applications. QoS protocols are essential in MANETs where different applications have different requirements, such as real-time communication where latency and throughput are crucial. Furthermore, the Internet of Things, IoT, has opened up new opportunities for MANETs. IoT devices connected to MANETs can form a dynamic network that can provide real-time information about the environment. This information can be useful in applications such as smart agriculture and environmental monitoring. Finally, machine learning and artificial intelligence are being used to improve the performance and security of MANETs. These technologies can help identify patterns in network traffic to optimize routing and reduce congestion. They can also detect security threats and identify the behavior patterns of malicious nodes. Mobile ad hoc networks, MANETs, have opened up a new world of wireless communication in situations where there is no pre-existing infrastructure. Such networks have become an essential communication medium in disaster response, military operations, remote areas, and transportation, to mention a few. MANETs operate on the principle of decentralized and self-organizing mobile nodes that act as a source, router, and destination. Although MANETs offer many advantages, they are not without their challenges. One of the biggest advantages of MANETs is their flexibility and ability to adapt to changes in topology and node connectivity. These networks are highly autonomous, thanks to the self-organizing nature of their mobile nodes. MANETs also make it possible to set up wireless communication channels in remote and hard-to-reach areas. For example, off-grid communities can use MANETs to communicate one another without relying on expensive communication infrastructure. On the downside, MANETs are vulnerable to security threats and have limited bandwidth and throughput. MANETs, being decentralized in operation, require trust relationships between nodes to build reliable communication paths. Such nodes are exposed to security threats by malicious attackers, making security an essential concern in MANETs. To address the challenges faced by MANETs, several routing protocols have been developed. Proactive routing protocols, such as DSDV and OLSR, maintain a consistent view of the network topology through a periodic exchange of routing information between nodes. Reactive routing protocols, including ODV and DSR, establish communication paths only when needed, reducing the network's overhead. Furthermore, hybrid routing protocols, such as ZRP, are being developed to combine the strengths of proactive and reactive protocols. ZRP makes use of proactive protocols within a local neighborhood, and reactive protocols when communicating over more extensive distances. Another area of ongoing research is in the development of energy-efficient routing protocols such as EAR and GEAR, which conserve energy while ensuring connectivity.